So now that you've got your push button working, you've managed to work with both an LED, which is an output, and a push button, which is an input. So in this section, we're going to look at combining them together so that you can control an output by way of your input. So we're going to join the push button circuit and the LED circuit together. Now you can follow along with one of the original tutorials, or we'll quickly follow along with what you need to know now. So we need to have our LED. So we'll put that in row 20. And so we want to make sure that the short leg, the flat slide, which is the cathode, goes on the left-hand side of this. And then we can connect row 20 into the ground power rail. So you can see that the real advantage of having a power rail is that you can then make lots of connections to it without running out of options for connections. So at this stage we know that we've got a ground connection here through our black jumper wire along row 20 and into the leg of the LED. Then we also want to have our resistor. Now, one thing with the resistor is it doesn't actually matter whether the resistor goes on one side or the other side of the LED. So before we had the connection going through on the ground side to the resistor. This time we're going to plug the resistor onto the side which is connected to our output. So we're going to plug one leg of the resistor into row 20, and then the other leg will go into row 24. And so now we have our connection going along ground, through the jumper, along row 20, through the LED, along row 20, and then through the resistor into row 24. And then finally, we want to connect from row 24 into pin 13. And you'll notice, of course, that I had this disconnected from the power before I changed the circuit, right? So now that we can trace along from our ground connection into our ground rail, through to our black jumper, and then along here in row 20, through the LED, into row 20 on the other side, through the resistor, and then into row 24, and then through the green signal wire to pin 13. So now let's look at the software side of what we need to do to control this. If you look at the examples, File, Examples, Digital, and Button, there is helpfully an example that we can use. So as the description says, it will turn the LED on and off depending on how you are pressing the button. So once again, we want to connect our Arduino to our computer and then upload the sketch. So it's compiling the sketch and then transmitting it. And so now, instead of us pushing the button, sending a serial message back to the computer, it's actually going to directly control the LED. So let's try that. So we push the button and the light comes on. And then we let go of the button and the light comes off. So you've just made a really, really expensive flashlight. But it works. So the next thing we're going to look at is, this is all very well, but you don't want to drag your laptop around with you. So how can we power this without the laptop? So we're going to look at using a 9-volt battery holder. Okay, so we've got our 9-volt battery holder. We simply need to unscrew it and then slide the lid off. Then get a 9-volt battery and insert it. Make sure it's the correct orientation and push it in to make a solid connection. And then simply replace the lid and put the screw back in. So one of the nice things about this particular 9-volt battery holder is that you have an on-off switch to it, which is kind of handy. So first of all, make sure you disconnect your Arduino from the computer, and in fact, because we're going to power it off the 9-volt battery and not USB, we don't need the USB cable. So the first one lead that we want to connect is the black one, and that goes into the ground connection. So again, it's handy that there's multiple ground connections on the Arduino because that makes it easy. Now, one thing to watch with the other lead, which is the red lead of the battery holder, is that it doesn't go into the 5-volt connection. If you put it into the 5-volt pin, then that will actually damage potentially the Arduino. So we want to put it into the pin labeled V-in, which is this pin here. So that stands for voltage in. So what happens is that the Arduino will take the 9 volts that comes from the power supply in the battery and turn it into 5 volts that the Arduino can use to power its brains there. So double checking we've got the leads in the right place. We've got the red lead going into V-in, voltage in, and then we have the black lead going into ground. So now when we turn the switch, we are powering our Arduino, and we can tell that it's on because it's got a label, and then we should now, when we press the button, have the LED turning on, and then letting go, and it'll turn off. Turn on, turn off. So you've made a slightly less expensive flashlight, but the difference is that you've made something. You've made something tangible. So it's not like creating software where you create something and it only ever exists on the screen. Now that you have your Arduino flashlight, as it were, you can actually take it with you. So you can go and show it to all of your friends. So let's go do that now. Oh, I was so excited about my Arduino flashlight that I forgot to tell you how our sketch works. Let's take a look at that now. So you'll see at the top we've got a comment which tells us what the sketch is going to do. So if we scroll past the comment, we can take a look at the code. So the first section that we have has some variables which are declared as constants, which mean that they won't change. And here we've got our button pin, which is pin 2, and as before our LED pin, which is pin 13. Then after that we set up a variable which does change, and that is the button state variable. So when we read the button state, if it's high or low, then we'll store that value in this variable. In the setup section, we are setting the pin mode of the LED to output because we're going to be turning it on and off. And then we set the pin mode of the button pin to input because we're going to be reading from that. Next, if we look at the loop, at the beginning of the loop, we read the state of the button pin and store that value in the button state variable. Then we make a choice about what happens next based on whether the button was high or low. So with our flashlight, if the button is high, which means that the button is pressed, then we also want to make the LED high, so turn it on. If the button isn't pressed, then we want to turn the LED off. So we set the value to low. Now, a flashlight's cool and all, but you think maybe a reverse flashlight would be better. So when we press our button, in fact, the light will turn off, and when we let go of the button, it will turn on. So we can make this work by making a change to our sketch. Often there's more than one way to achieve your goal, so the way we're going to do it is we're going to change this high to a low, and then this low to a high. So that means that the decision that is made is if the button is pressed or high, then we're going to turn the light off. And when the button isn't pressed, then we're going to turn the light high or on. So let's update the sketch now. Now, when your Arduino is connected to the battery, it's possible to plug it into USB, and the Arduino will intelligently switch between the two for power. So let's go ahead and upload that. So it's compiling and then uploaded the sketch. And now we can disconnect our USB. And now you'll notice that the light is on and we're not pressing the button. And when we press the button, the light goes off. Let go of the button and the light goes on again. So we have our reverse flashlight. So let's go and show our friends our reverse flashlight, which is so much cooler than a normal flashlight.